All right, this is part 2 of 3.4. So our objectives are here. And yesterday we got all the way through, almost actually all the way through 1 through 4. I have to show you one more thing on 1.4. And then I don't know why I said 1.4. 1 through 4. And then I have to show you Descartes' rule of signs. Okay? So, linear rationalization theorem. So yesterday we talked about if they give you these zeros, we can go to write the factors. We multiply those out to get the polynomial, and then we figure out, based on what we're given, what our multiplier needs to be so that what they gave us is true, is real. Okay? So the quote-unquote problem comes if it gives you something like this, right? And it's not a problem so much as it is you have to remember something, okay? Because if it gives you a zeros of 4 and 2i, there's automatically another 0 that they didn't give you that you know is there. Do you know what it is? If you have a 2i, what else do you also have? Negative. Negative 2i. Okay? You remember that? Because when we get the I from taking the square root of a negative number, and if we have a positive one, we also have a negative one. So please don't forget that when you're going through here. Okay? All right, any questions about that? All right, so let's talk about Descartes' rule of signs. Okay? So let me give you an example. F of x equals 3x to the 7th minus 2x to the 5th minus x to the 4th plus 7x squared plus x minus 3. Okay, so there's our polynomial. Everybody okay so far? Okay, so what Descartes' rule of signs says, let me use blue so we're a different color here. It says that the number of positive real zeros of f is either A, the same number of sign changes of f of x, or less than that by a positive even integer. So the number of positive real zeros of this function right here is either the same number of sign changes of this function or less than that by a positive even integer. Can I explain what I mean? Okay, so if we look at this function right here, do you notice that this number is positive? Yeah? So from here to here, is there a sign change? So that's 1. From here to here, is there a sign change? No, because those are both negative, right? From here to here, is there a sign change? So that's 2. From here to here? No. What about from here to here? Yes. So how many sign changes are there? There's 3 sign changes. Okay? So the number of positive real zeros is either 3 or less than that by a positive even integer. Guys, what's the most popular positive even integer? 2. So less than this number by 2. Well, what's this number minus 2? 1. So if I ask you how many positive real zeros this has, it either has 3 or 1. Now, it doesn't tell us what they are, but it tells us how many to look for. Does that make sense? Okay. So, next option is what? The number of what? negative real zeros? Yeah? Negative real zeros. So the number of negative real zeros of f is either, or either, I don't care, I hope you don't either, the same number of sign changes as f of negative x, or less than that number by a positive, even integer. So almost the same kind of thing, right? But what we have to do is we have to take all of the x's in our original function and change them to negative x's. Okay? So can I show you an example of that? All right. I'm going to rewrite this function that's up top down here so it's a little bit easier for us to see. So our function was f of x equals 3x to the 7th minus 2x to the 5th minus x to the 4th plus 7x squared plus x minus 3. Okay? So what I need to do is every x, I need to change it to a negative x. Okay? Now if I change it to a negative x, what happens if I raise a negative x to the 7th power? So I've got 7 x's. Every 2 is going to keep the same sign, right? Because a negative times a negative is a positive. So positive, 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 negative. So this is going to end up being negative 3x to the 7 now. Now I have x to the 5th, 5, so a negative, so that's going to change the sign, all right? Well, it was negative, what's it now? So positive 2x to the 5th. What's going to happen with this one? There's 4, so if it's still both positive, is it going to change the sign that's there? No, it's not. So minus x to the 4th. Thank you. Is this one going to change the sign? Because it's squared. So that's going to still just say plus 7x squared. Is this one going to change signs? Well, that seems kind of obvious that it is, right? Because it was an x, now it's a negative x. So minus x minus 3. So did you see a pattern there at all? We only did 4, but... So when there's odds, right? The odd integers are going to cause the signs to switch. The even integers, the signs did not switch. Does that make sense? Now we do the same thing we did before up here. We look to see the sign changes. Well, that's a sign change. That's a sign change. That's a sign change. That's a sign change. And there's not a sign change there, is there? Okay? So how many sign changes are there here? 4. So there can be 4 or, what do you think? 2 or 0. Because we're going to subtract 2 every time, right? Less than that number by a positive even integer. Okay? Now the only time this, and it doesn't even really make sense, but I'm going to tell you anyways, okay? What if we did all the things that we were supposed to and got one sign change? How many sign changes are there? 1, right? Because there can't be 1 or... We can't subtract 2 from 1, can we? Because that would give us -1, and that wouldn't even make sense. So if this one has 1 sign change, then it really does exactly have 1 negative real 0. All right? There's no subtracting 2 from that. It's only the A. Because all the other stuff we said it's either A or B, or either A or B, whatever you want to say. But if it turns out that there's one sign change, it's only one. It's not A or B there, it's just A. Does that make sense? Okay. Any questions about Descartes' rule of signs? Any questions about any of these other objectives that we talked about?